Okay, today we're going to talk about parallel and perpendicular lines. One example I always love to give students in terms of where parallel and perpendicular lines may be important is when planning a city. So when city planners design a city, they often use a Cartesian plane, also known as a coordinate graph. And we should know in a coordinate graph, we typically have 4 quadrants, and the point in the middle is called the origin, represents 0, 0. And they often use this to, like a Cartesian plane or coordinate graph, when they're designing where the street should be. Think of an intersection in your town, right? They usually are crossing at a 90-degree angle, or at least the street on one side of the intersection kind of has to match up to the street on the other side of the intersection. It always doesn't, but most of the times, more times than not, it does. So 2 concepts that help designers do this are parallel and perpendicular lines. We should know that parallel lines never cross one another. Right? So these lines will go into an infinity and they never cross each other. So in order to make that happen, what must be true about those lines is they must have the same slope. And different y-intercepts. So think about when you graph a linear equation. We start with the b and we move with the m. In other words, a y-intercept is one specific point on the graph, whereas slope tells you how to get to another point, how much you rise and run, so that you can keep on going to additional points on the line. So if you think of a race and you're starting the race and you and your best friend are racing and you run exactly at the same speed. So if you're running exactly at the same speed and you start from exactly the same spot, you should basically finish at the same time, right? Or if we're looking at the race, we would see only one of you running if we're looking at it sideways. So when you think of 2 lines, imagine they're starting from different spots. So say you give your best friend a head start in the race. If you're both running at the exact same speed, you will never catch up to your bestie because you're running at exactly the same speed, but you haven't started at the same spot in the race. And that's parallel lines. They will never, ever touch. While perpendicular lines transect at a 90-degree angle, or what we call a right angle. So the slopes of the 2 lines that are perpendicular must be opposite, meaning if one is positive, the other one has to be negative. If one's negative, the other one must be positive. And reciprocal. So we should know what a reciprocal is by this point. So if we have a perpendicular line with a slope of 3, the opposite of a positive 3 is a negative 3, and the reciprocal is 1 over 3. So a line with slope of 3 and the other perpendicular line would have to be negative 1/3. So opposite and reciprocal to each other. And when they cross over, they create 4 90-degree angles in the middle. That would be typical of a normal intersection, right? Where you have 2 streets transecting each other, and they're creating those 90-degree angles in between. So when we're looking for parallel lines, we should know that the slope is going to be the same between the 2 lines. And the y-intercept is going to be different. So in order to prove, because that's where we're at in math, we can't just say, oh yeah, they look parallel. We have to prove it with the math. So if we're given a graph, we're going to have to find the slope of the two lines to determine if they're parallel or not. If it's an equation, hopefully it's in the form y equals mx plus b, and we look at the m's and be like, oh, these are the same m's. Then we look at the y-intercepts, oh, these are different, therefore these must be parallel. So we must use mathematical reasoning in order to prove something correct. Perpendicular lines. Also, you'll notice this 2 after here, that's not a Roman numeral 2. This is how we identify parallel lines. It's just 2 lines going up and down. Perpendicular, we can see here, we have 2 lines meeting that create 90-degree angles right there. So for perpendicular lines, our slope is opposite and reciprocal. Must be both in order to be perpendicular. And the B can be same or different. So the reason that is parallel lines never meet. Perpendicular lines are going to intersect once. And that intersection may occur at the y-intercept. If that does, they're going to have the same y-intercept. Or it may occur at a different location in which they'll have a different y-intercept. So it can be either or with perpendicular lines. So those are the things we're looking for to determine or prove parallel and perpendicular lines in linear equations. So let's look at what you have to do. Change the size of this. So you have one side that's parallel, one side that's perpendicular. It says on the left, match the equation of the line that is parallel to the provided equation. On the right, match the equation of the line perpendicular. I'm sorry, on this one, match the line that is parallel to the provided equation. On the right, match the equation of the line perpendicular to the provided equation. So these kind of all break apart. So I'd probably bring them all out so I can see all of them, be able to read them pretty easily. These are all going to be the perpendicular ones. So I'm just bringing them out so I can see them all to make my life easier. We'll do one of each together. Okay. So parallel lines, going back, rule, slope has to be the same, b must be different. We should know y equals mx plus b. So y equals 1/2 x plus 4. Half is the m, 4 is the b. So I need to find another equation that has a slope of 1/2. So I do that first. Well, this one right here has a slope of 1/2. No other ones have a slope of 1/2. And you'll notice different intercepts. This is 4, this is 3. So this one is going to go on top here. The other side, y equals 1/2 x plus 4, so same. What's going to be perpendicular to this? So the slope isn't going to be 1/2. So this is positive. I'm looking for opposite, which would be negative, and reciprocal, which is 1/2 flipped over to be -2/1. So -2/1 would just be -2. So I'm looking for a slope of -2x, and the intercept could be same or different. So y equals -2x. -2 as a slope is opposite and reciprocal to 1/2. So this has to be 1/2. And I had to make them a little bit bigger so that the equation would fit. So no big deal if they overlap there. So that's what you're going to go through and do on each one. On 65, ask you the following question. It says, given two parallel line segments on a graph, answer the following questions. Write the equations of two lines that could be used to create a square with the two line segments. So what lines would you need to be able to connect these 2 points and these 2 points? What are the equations of those lines? So we're going to list the first equation here, second equation here, and then explain how you thought about it and how you worked through what you needed to do. And that is it for parallel and perpendicular lines.